So this is section 6.4 continued. We're going to start talking about reference angles. When we talk about a reference angle, we're looking at the positive acute angle that's formed by the terminal side of your angle and the x-axis. So looking at this first picture, we've got the x-axis, so the positive x-axis is our standard position. We rotate up, we have our terminal side. So our reference angle, in these cases, T prime equals the reference angle. So in this first picture, our angle is right there. We're in the first quadrant. And if we're thinking about the acute angle that's formed with the x-axis, it's just itself. So in this case, T prime, the reference angle, is equal to the angle itself. If we look at a second quadrant example, say we have an angle T right there that goes into the second quadrant. We want to form our reference angle, which is going to be acute. So we're going to take from the x-axis and we're going to go up to our other angle, so this is our terminal side of the angle. So we want to find this angle is our reference angle. So if we're thinking about that, this is pi, because you have 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi when you're thinking about your radian measures. So if we're looking for this angle, we're going to take pi and subtract our given angle to find that reference angle. A third quadrant example.
What is your given angle for that one?
This is just any given angle. We're not actually finding the specific reference angle.
Okay.
It's just angle T, we're calling it. So for a third quadrant angle, we're rotated into the third quadrant. This is our terminal side. So we want to find the reference angle, which is the acute angle to the x-axis. So that would be this angle right here, because we go from our terminal side, make the acute angle with the x-axis. Again, this is pi over here. So if we have rotated past pi, you're going to take your angle that's in the third quadrant and subtract pi, and that'll give you your reference angle there. For the fourth quadrant, we rotated all the way to the fourth quadrant, and we're looking for the acute angle that's formed with the x-axis and our terminal side. So that would be that angle would be our reference angle. And again, we said if we've made a full rotation, this is 2 pi. So if we don't have quite 2 pi, you can take 2 pi minus your angle that you're given that's in the fourth quadrant, and that'll give you your reference angle. So that's how you find a reference angle in each of the quadrants. So example 3, it wants us to use reference angles to find the exact value of sine, cosine, and tangent for each of these. So first, for part A, we should find our reference angle. So for part A, if we go 3 pi over 4, 3 pi over 4 is in the second quadrant. So we're going to take T prime, or our reference angle, equals pi minus 3 pi over 4. So we're gonna get 4 pi over 4, when we get a common denominator, minus 3 pi over 4. So you end up getting pi over 4. So, can anyone tell me what pi over 4, what angle pi over 4 actually is in degrees?
60.
Just kidding. It's 645. 145.
Yeah, 145.
So pi over 4 is a 145 degree angle.
Is that 45 degrees?
Pi over 4,
35 degrees?
Oh, pi over 4?
just pi over 4, our reference angle.
That would be 35.
Pi over 4,
It's awesome. Yeah, it's over.
pi over 4 is a 45 degree angle.
Okay, I did the other part, not, I know what I was doing.
So if you don't remember that this is a 45 degree angle, you can multiply by 180 over pi, and that would give you 45. But you should know that pi over 4 is a 45 degree angle.
I hate myself.
So now, if we're finding sine, cosine, and tangent, so sine of pi over 4, or a 45 degree angle. And remember, we need to take into consideration what quadrant we're in. So this is where knowing what sign each quadrant has for each ratio comes into play. So sine, when you're in the second quadrant, remember sine was your y coordinate. So here, your sign should be positive still, because we're in the second quadrant. So sine of pi over 4, or sine of a 45 degree angle, was square root of 2 over 2. And again, it might be helpful to draw your triangles if you don't remember. Remember, your legs are 1, your hypotenuse is square root of 2. So when you're finding sine, it's opposite over hypotenuse, and then rationalizing it.
Okay.
So cosine of a 45 is the same thing,
But I think that's easy.
but now you have to take into consideration that you're in the second quadrant and your cosine should be negative. So it should be a negative square root of 2 over 2. And then your tangent of pi over 4 would be just 1. But again, because we're in the second quadrant, your tangent is negative, so it's negative 1. So you need to know how to find not only the sine, cosine, and tangent, but you need to realize the signs of those ratios in each quadrant. So for part B, we're given 4 pi over 3. So 4 pi over 3 is in the third quadrant. So we're going to use t prime equals your angle, so 4 pi over 3. And we're subtracting pi because we want to find this acute angle. So getting a common denominator, you get minus 3 pi over 3. This equals pi over 3. What's pi over 3 for an angle?
Third. No. Oh, 60.
Pi over 3 is a 60-degree angle.
Does it take 3 of those to make 180? So 180 divided by 360.
So now we need to find the sine of pi over 3, the cosine of pi over 3, and the tangent. So the sine of pi over 3 is square root of 3 over 2. And again, if it's helpful to draw the triangle, draw the triangle. Remember, your shorter leg was 1, your longer leg is root 3, and your hypotenuse is 2. So if you're looking for sine of, we're looking at the 60-degree angle. So you have root 3 over 2. And again, we need to take into consideration what quadrant we're in. So sine in the third quadrant is negative. So this is a negative square root of 3 over 2. Our cosine. So if we look at our picture, our cosine is adjacent over hypotenuse, so it'd be a 1/2. But again, cosine in the third quadrant is negative, so it's a negative 1/2. And then our tangent of pi over 3 is opposite over adjacent, so it's root 3. And tangent in the third quadrant is positive, so it is just root 3. So part C. Part C, we have 11 pi over 6. If we draw 11 pi over 6, we end up in the fourth quadrant. So we need to find that reference angle. So in the fourth quadrant, you're taking t prime equals 2 pi, and you're subtracting your angle, so 11 pi over 6. So you're going to get 12 pi over 6 minus 11 pi over 6. So you get 30 pi over 6, which is your 30-degree angle. So again, we're going to find sine of pi over 6, cosine of pi over 6, and tangent of pi over 6. So sine of pi over 6, looking at our picture, sine is opposite over hypotenuse, which would be 1/2. And in the fourth quadrant, sine is negative, so it's a negative 1/2. Cosine of a 30 is root 3 over 2. And in the fourth quadrant, cosine is positive, so it is just root 3 over 2. And tangent of pi over 6 is opposite over adjacent, so it's going to be root 3 over 3. And in the fourth quadrant, tangent is negative, so it's a negative root 3 over 3. So that's combining the reference angles and finding the sines of the different ratios in each one. So then the last thing that we're going to go over is coterminal angles of the trigonometric ratios. And what this says is that any trig function is equal to the same trig function as long as it's a coterminal angle. So any coterminal angle of a given angle will have the same trig functions. So looking at example 4, it wants us to find the sine, cosine, and tangent of 7 pi over 3. So 7 pi over 3 is a full rotation and then a little more. So we can write 7 pi over 3 really as 2 pi over 3, because if we multiply this out, it's 7 pi over 3. So this is an integer multiple of pi over 3. And pi over 3 again was our 60-degree angle. So this part is a 60-degree angle. So we just need to find sine pi over 3, cosine of pi over 3, and tangent of pi over 3. And we're in the first quadrant, so they're all positive. So sine of pi over 3 is just root 3 over 2. Cosine of pi over 3 is 1/2. And tangent of pi over 3 is root 3. And again, if you don't remember those, draw your triangle. And so that's using coterminal angles to find the sine, cosine, and tangent. And we're done.